Hey guys, today we are starting Unit 3 and we're starting by talking about sequences and series. So first go ahead and pause the video and read over this and write down the notes, and then I'm going to keep talking about it. So starting with a sequence, it's literally just an ordered list of numbers. So a sequence is gonna have some either common difference or common ratio, depending on if it's arithmetic or geometric. So today we're only talking about arithmetic, and so that means you're adding the same number each time. So that's going to be a sequence. A series is when you're combining the numbers that are in a sequence. So in this case, you're just adding each number as you go. And then there's going to be two different types of formulas, which are going to be on the next slide. The recursive formula just tells you the next term that you're going to find. So like in the first example, you have 4 terms, 1, 4, 7, 10. And so the recursive formula would help you find that fifth term. The explicit formula is going to be how you find any term. So like if you had 1, 4, 7, 10, then you could use the explicit formula to find, for example, the 27th term or the 103rd term, and so on. So then these are going to be those actual formulas, and I detailed like what each of the things, each of the terms in here mean. So go ahead and pause and write these down as well. So with these formulas, you're going to be able to have the formulas on tests and quizzes and stuff like that. It's something that you're not going to have to memorize, but it is going to be helpful if you have a good general idea of what they are without having to look back each time. So for the recursive formula, it's basically like the term that you have now is going to equal the previous term plus the common difference. And then that's just for arithmetic, the common difference, because it's what you're adding each time. The explicit formula, so it's like any term that you're trying to find, is going to equal the first term plus n minus 1, and n is going to be the number of the term you want. So if you want the 10th term, then this n minus 1 right here, you would use 9, and then it's going to be times the common difference. And so we're going to do a couple of examples where you guys can see what that looks like. So starting here, we have find the recursive and explicit formulas for each. And so I have both up here so that you can see them. So starting with finding the recursive formula, it would just be a sub n equals a sub n minus 1, so that's the previous term, plus the common difference. So then you have to find like what number are you adding to each term to get to the next term. So to do that, you can basically take the next term and subtract the previous term. So like 11 minus 7 is 4. So to get from 7 to 11, you're adding 4. To get from 11 to 15, you're adding 4. 15 to 19, you're adding 4. So that's going to be your common difference. So it's going to be plus 4. So that would just be the recursive formula. Then if you wanted the explicit formula, it would be a sub n, so the term that you're trying to find, equals the first term, which is our 7, plus n minus 1, times the common difference, which is 4. So then we want to use that to find the 100th term. So that means we're looking for a 100. So that represents that a sub 100 represents the 100th term in this. And that's going to equal 7 plus n is 100 minus 1 times 4. So then you would just work that out. So you have 7 plus 99 times 4. And then you can just type that into your calculator, which I don't believe mine is working at the moment, but you would type that into your calculator to solve it. So I'm going to pause that and get this calculator working and do that real quick. Okay, so what we had was 7 plus 99 times 4, and we end up getting 403 as our 100th term. So then, if you want to, I would recommend go ahead and pause the video and see if you can do example 2 on your own. So I'm going to scroll back up to the top so you can see both of the formulas, and then unpause when you're ready to see me do it. So to do example 2, first I'm going to do the recursive formula. So I would have a sub n, and I wanted that to be blue. So a sub n equals a sub n minus 1. So the current term equals the previous term plus the common difference. So to get from 23 to 30, you're adding 7. To get from 30 to 37, you're adding 7. From 37 to 44, you're adding 7. So a sub n minus 1, and then it's going to be plus 7. So then I need to do the explicit formula. So I'm going to have a sub n equals the first term, which is 23, plus n minus 1, and it's going to be times 7, because that's our common difference. So then in this one, it asks us to find the 200th term. So that's going to be a sub 200 equals 23 plus 200 minus 1 times 7. So then to finish solving that out, you would have 23 plus 199 times 7, and you can work that out in your calculator. So it's 199 times 7. And that should give you 1,416. So that's going to be the 200th term of that sequence. So then we're going to talk about the sum of arithmetic sequences, and again, I want you to just pause this and write all of this down and unpause when you're ready to hear me talking about it. So in a finite arithmetic series, which a series means that you're adding each of the terms, you can find the sum of all of the terms. So this represents, S sub n represents that you're finding the sum rather than just finding one of the terms. So you're finding the sum of the terms up to the nth term. And it's going to equal n, so like the number of terms that you're adding up, divided by 2 times the first term times the plus the last term. And then to find that last term, that a sub n, you're going to have to use the explicit formula from the last slide to find that. And then this can also be written in sigma notation, which is just this fancy looking E here. That is the Greek letter sigma. And so you may see it written like this. It's just saying it like I is going to be the number of the term that you start with. So it wants you to add from the first term to the nth term. And then a sub I is going to give you the equation of the sequence. So whenever it gives you the equation, it's just telling you how you find a sub n, rather than, it's basically giving you the explicit formula without you having to figure it out yourself. So we are going to go into some of these. So find the first one, or find the sum of the first 100 terms of this. So this is going to be kind of long, but that's okay. So the first thing that you're going to want to do to be able to find the sum is you're going to have to find a sub n. So that's going to be a sub 100. So we need to figure out what the explicit formula is before we can do that. So we're going to have a sub n equals the first term, which is 7, and then plus n minus 1 times the common difference. So to get from 7 to 11, it's plus 4. 11 to 15 is plus 4, and so on. So our common difference is going to be 4. So then it says, or we need a sub 100, and I think these are the same ones that we had on the last slide, and they are. So we have that a sub 100, it's going to equal 403. And so then we're going to use that to find the first 100 terms, and the first 100 terms is going to be written as S sub 100. And so S sub 100 is going to be n divided by 2, so that's 100 divided by 2, times the first term, which is 7, plus the last term, which is 403. So 100 divided by 2 is going to be 50, times 7 plus 403 is going to be 410, and then you're just going to multiply those together. So 50 times 410 is going to give you 20,500. And then it says up here, write in sigma notation. I'm not going to worry about that too much, but just so that you can see what it would look like, you would have the Greek letter sigma, and then at the bottom, and this can be written either in this area or in this area, so you may see it either way, but I'm going to write it on the very bottom. You would have I equals 1, because that's the term that we're starting with, and we're going from 1 to 100. And then you would have the formula for the sequence that you're using. So it would be 7 plus n minus 1 times 4. And so then if you plugged in 1 for n, then that would give you the term. That's the explicit formula, essentially. So having this is the same as doing this formula where you have S sub 100. It's just using different notation, but you need to be able to read that notation in case you see that as well. So again, I would like for you to try to pause and do example 2 on your own, and then unpause when you're ready to see me doing it. And since we already did the A sub n, since we already did the explicit and recursive formulas and found A sub 200, I'm going to use that. So it's the 23 plus n minus 1 times 7, and then the A sub 200 is 1416. So A sub 100 was 1416. So then, or it was 200, not 100. So then when I'm finding the sum of the first 200, I would do 200 divided by 2 times the first term, which is 23, plus the last term, which is that 1416. And then if you want to, you don't even have to simplify all of that first. You can just type that whole thing into the calculator. So we had, not math, we had 200 divided by 2 times the first term, which was 23, plus the last term, which was 1416. And then that gives you 143,900. And then that's going to be the sum of the first 200 terms. And then if you were writing it in sigma notation, then you would have sigma. And then I need to write that a little lower so that I can write the number on top. So you would have sigma, and then the first term was 1, the last term was 200, and then the explicit formula that you would want to put in there was 23 plus n minus 1 times 7. So 23 plus n minus 1 times 7. So that would be in sigma notation, and it would still just equal that same 143,900. So I just wanted to do one more example on this from start to finish without already having any of the information given. And so we need to write each of these in sigma notation and then use the S sub n formula to solve. So starting with sigma notation, we need the first term, so like I equals 1 to the 100th term. And then we have to write the explicit formula. So the explicit formula is going to be 9 plus n minus 1, and then times the common difference. So to get from 9 to 4, we're actually subtracting 5. To get from 4 to negative 1, we're subtracting 5, and then so on for the rest of these as well. So my common difference in this case is going to be a negative 5. So then I need to use my S sub n formula to find the first 100 terms. So instead of S sub n, we can do S sub 100, and it's going to equal n divided by 2, so that's 100 divided by 2 times the first term plus the last term. And that last term is the one that we're going to have to find using our A sub n formula, the explicit formula right here. And so that is going to be my first term, which is 9, plus n minus 1, so that's 100, minus 1 times negative 5. So then if I'm solving that out, it's going to be 9 plus 99 times negative 5. So 9 plus 99 times negative 5 is going to be negative 486. And then that is the number that I'm going to put in here for A sub 100. So then I just need to finish solving that out. So 100 divided by 2 is going to be 50 times 9 plus negative 486 is going to be negative 478 or 77. I believe. I'm going to type in the whole thing just to make sure. So then I just need to calculate that. So it's 50 times 9 plus negative 486, and you get negative 23,850. And then these are separate. And that would be your answer. And then I'm not going to do example 4 right now because you should have the general idea down. So we're going to go to a word problem instead. Okay, so this is kind of just how this is going to be applied. So John wants to create a brick patio in the shape of a trapezoid. So his patio is going to be in this general shape. The first row will consist of 15 bricks, and the second row will have 17, and the pattern will continue. So the third row would have 19. So basically the common difference is going to be 2 for each row. And then he needs 120 bricks to cover the entire area. So we want to know how many bricks are in the last row. So that's going to be coming from that S sub n formula. And so that's where you have n divided by 2 equals the first term, which is, well, 15. I wrote equals, I meant times. So n divided by 2 times the first term, which is 15, and then it wants to know how many bricks are in the last row. So A sub n. Okay, I think I said that wrong. He actually needs 120 rows of bricks, not 120 actual bricks. So the S sub n stuff is actually going to go down here where we're trying to figure out how many total bricks he needs. But the first thing we need to figure out is just how many bricks does he need in the last row. And it tells us that there are 120 rows. So that's where we have to use that explicit formula. So we would be looking for A sub 120. And then that's going to equal the first term, so that's how many bricks are in the first row, which is 15. And then plus n minus 1, so that's going to be 120 minus 1, times the common difference, which is how many bricks we're adding each time, which is 2. And so then I'm just going to go ahead and calculate that to tell me how many bricks are in the last row. So that was 15 plus 119 times 2. And that tells me 253 bricks are in the last row. So then once I know how many bricks are in the last row, that can help me figure out how many he needs to order. So how many he needs to order is going to be the sum of all of the bricks in the 120 rows. So that's going to be S sub 120. And that's going to equal n divided by 2. So that would be 120 divided by 2 times the number of bricks in the first row, which is 15, plus the number of bricks in the last row, which is 253. And then you would just calculate that to find out how many total bricks he needs. So that was 120 divided by 2 was 60 times 15 plus 253. And that's going to give us 16,080. So he needs 16,080 bricks. So here's another example, and my suggestion again is to pause it and read it and try it on your own. And then if you can't get it, watch the rest of the video, or if you do get it, then watch how I solve it to make sure that you got it correct. So in this one, you're determining the seating capacity of an auditorium with 30 rows if there are 20 seats in the first row, 24 in the second, 28 in the third, and so on. So if we're determining the seating capacity, then that means all of them added together for the first 30 rows. So that's going to be S sub 30. And then, so it's 30 rows, so that would be 30 divided by 2 times the number of seats in the first row. And there are 20 seats in the first row, plus the number of seats in the last row. So we have to find the number of seats in the last row by doing the explicit formula for A sub 30. And then that is going to equal the number of seats in the first row, which is 20, plus n minus 1, so that's going to be 30 minus 1, times the common difference. And the common difference, it goes from 20 to 24 to 28, so we're adding 4 each time. So then we're going to evaluate 20 plus 29 times 4. So 20 plus 29 times 4 gives us 136 seats in the last row. And so that is what goes into this summation formula. And then I need to actually evaluate that so that I can find the seating capacity of the auditorium. So 30 divided by 2 times 20 plus 136. So 30 divided by 2 is 15 times 20 plus 136. And that is going to equal 2,340 seats in the auditorium. So that pretty much sums up arithmetic sequences and series. So you should be good to go work on your homework for that.